Yo, welcome to Alex Academy, and in this video series, we're going to talk about AP Physics. So what is physics? Physics is a study of fundamental laws of nature, so basically how physical phenomena in the universe behave and react with each other. Also, lots of physics can be written in math equations, and so you'll see a lot of math in physics, and math is really important when it comes to physics. Also, in physics, we make observations, and these can be both theoretical and experimental. Usually, they help each other to prove the observations as correct. And finally, there are only a few fundamental ideas in physics, and based on these fundamental ideas, we can build all sorts of other physical properties and ideas based on these, so we must learn these. So now that we know what physics is, let's sort of dive into sort of the underlying structure of it. So physics uses the SI system, and SI stands for Standard International, which is basically French. And it uses the system because it's really easy, it's based on units of 10, and it's really easy to convert back and forth. So basically, SI system, in physics we use MKS, which is simply defined as M for meter for length, K is kilogram, and kilogram is mass, and S is second, and that's used for time. So this is basically what we use in physics. There are also acceptable versions that we can use called CGS. This is basically just like the MKS SI system, except this uses even smaller units. So you have C is centimeters for length, G you have grams instead of kilograms, and S is still seconds. So the S is always the same. And then you also have a third system, which is the British engineering system. And the British, they like to use stuff such as the foot for length, the slug for mass, and seconds for time. And in this is mainly used by engineers, so we won't use it that much, but we might encounter it. And as we said earlier, the units of 10 are very important because everything builds on 10 and the exponents above and below it. When actually doing physics, we use two things. One is significant figures, and this is a separate topic, but basically it's just deals with zeros and numbers that are significant, and it really talks about the precision and accuracy of numbers that we use. Also, we have dimensional analysis, and dimensional analysis can really just be used to help convert different things. So if you're going from different units of 10, as we saw here, you can use dimensional analysis to help you sort of see how the numbers relate to each other and match up, and it's really just multiplication. In order to cap it all off, we can do some actual physics. Two important concepts to know are scalar and vector. A scalar is basically a numerical value, and basically it's expressed in terms of appropriate units. So an example would be temperature of a room or speed of a car. It's basically something that doesn't have direction. Vector, on the other hand, is a mathematical quantity with both a numerical value and a direction. So this would have num value and direction, while a scalar really just has a numerical value. And so this would be like the velocity of the car, the speed and which direction it's traveling into. And so certain things are scalars while other are vectors. So for example, scalars include time, and it also includes length, mass, volume, and density. And vectors, there are also a lot. For example, you have force, acceleration, and momentum. And these things we will dive into a little while later, but this is basically just an introduction to the sort of things we'll encounter in physics. And also, one final note, when working in one dimensions, we use the signs plus and minus, so this is really important because it allows you to know what we're really going at, so plus or minus. And eventually, we'll also figure out if it goes up or down. And this really just helps us get everything straight when we're working with vector quantities. So this is also very important.